Hello friends, welcome to SahuStudies. In this video, we are going to see what is the difference between reduce by key and aggregate by key in Scala. So let's discuss about what is reduce by key first. So reduce by key is a transformation function and it is a wider transformation. It is a wider transformation. What does it mean? It means that data will be shuffled across different executor over network. It is used to merge the value each key. It uses associative reduce function on the PySpark to merge the value of each key. What does it mean? It means that whenever we are going to use reduce by key function over a RDD, it will use associative reduction function to combine the value of each key, and what it will going to do, it will return a RDD which has key and the aggregated value. It is a wider transformation as it is shuffle the data across different partition. As I mentioned that it is a wider transformation, so shuffling of the data will be going to happen. It operates on pair IDD, key and value pair. So whenever we are going to use reduce by key over a RDD, RDD must be a paired RDD. Means the data is stored in RDD in key and value pair. It is very useful when there is a requirement to perform aggregate function on the value which are associated with the key. So whenever we are going to perform any kind of aggregation value over the values of each key, this reduce by key will perform better. One of the main advantage of reduce by key is that it reduces the amount of data that needs to be shuffled and stored in the memory. Let's understand this point in detail. So when we are going to apply the reduce by key function on RDD, what Spark will going to do, it will do the aggregation first on the partition label, and then it will again aggregate all the value from the different partition to the respective partition. So at the first stage, when the aggregation is happening within the same partition, the amount of data reduced drastically. So suppose for in one partition there are 1000 rows are there. In 1000 rows there are only two unique keys are there. So data will be going to reduce from 1000 to 2 only. Why? Because the aggregation will going to happen on the each key. And for instance, if there is a sum aggregation, so the data will be aggregated like this. One key, its value, another key and its value. So there would be two key only and their corresponding aggregated value. So suppose in the raw data, the size of the data is 10 MB, the aggregated resultant data set which has only two data point, it may be possible that the size of the data will be only 1 kilobyte. So this amount of data will going to shuffle across different executors over the network. The speed will be very fast. That's why this is one of the main advantage of reduce by key. And most of the time we use reduce by key whenever we are doing any kind of aggregation over RDD because of this reason only. One of the main disadvantage of reduce by key is that it requires a reduce function that is associative and cumulative, which may not the case for all aggregate function. Means suppose we are doing any kind of other aggregation like mean, median or standard deviation. So those are not associative or cumulative. So that kind of aggregation will not going to be more performance optimized if you are going to use reduce by key function. Let's understand the reduce by key with the help of this pictorial representation. This is a one partition which is present in one executor. So there are two data points. On the same partition, it will, so suppose we are doing the sum aggregation, right? So what it will going to do, it will just sum, it will apply the aggregation function in this partition only, and will come up with this kind of a value. This is the key and this is the value. This is the key and this is the value. Since it has only one record for key A and key B, that's why it is the resultant. Its result is looks like this only. But suppose this is the executor. This is the partition which sits on different executor. It has two records for key 1 and two records in key B. So the this aggregation will going to apply in this partition only, and the resultant result will look like this. A is 2, B is 2, because this the key which has value A has come twice, and the value is 1 and 1, and if you add it, it will become A and 2, means A and the total value is 2. Same goes for B. Now let's see, this is the third executor, third partition which sits in different executor. It has 3 value for A key, 3 value for B key. Now here it is reducing, or here the aggregation is going to apply in this partition only. This is the sum aggregation, that's why the value A has the value 3 and B has the value 3, because here for each and every value of key B 1 1 1, so aggregation is happening, the value is 3, same for E. So here we have seen that first aggregation is happening on the partition level. So here is the sum aggregation. So sum aggregation is happening on the individually on these 3 partition. Now the shuffling will going to happen at the last stage. So this is the last stage. So after shuffling, how the distribution of data will going to be in a different partition. So this is creating a different partition in different executor. This is creating a different partition in a different executor, and the data is shuffling. How the data is shuffling? This value A is equal to 1 is the resultant of the aggregation which is done on this partition. A2 is coming from this partition. So this is the aggregated result of aggregation function which has been applied in this partition. This A3 is the value of the resultant aggregated result of this partition on which some aggregation has been applied. Same for B. Same for this partition. This B1 coming from this executor. So this is the resultant, or you can say this is the result of aggregated function which has been applied in this executor. B2, so it is coming from here. So this is the result of aggregation which has been applied over this partition. B3, this is the result of aggregation which has been applied over this partition for this particular key. Once the data has shuffled and sits in these two partition, again this aggregation function will going to apply in this individual partition, and we can say the resultant data is A is equal to 6 and B is equal to 6. 6 is the sum aggregation of this data. So here I try to make you understand how the reduce by key actually works in different partition, and how the data is shuffling from different partition to different partition within the executor over the network. Now let's discuss about aggregate by key. So aggregate by key is the fundamental transformation function. So this is one of the transformation function many times you use. It is optimized and it's a broader transformation. So aggregate by key is also an optimized transformation because the shuffling is taking place at the last stage of transformation, and aggregation function is generally applied on each and every partition first. And it is a broader transformation. Broader transformation means data will going to shuffle across executor over the network. It is helpful if there is a requirement of aggregation and the input and output are different. So most of the time there is a requirement that we need to do certain kind of aggregation, but the output of the aggregation is different. Whatever the output we are taking as an input in the aggregation function, or we can say the type of RDD which is over which we are just calling the aggregate function, the output may be different. It supports aggregation such as mean, max, average, and count, which we have discussed it, right? So it aggregates value of each key using combine function and neutral value, zero value, and return a different type of value for that key. So let's understand this zero value. So what generally it will going to happen whenever this aggregate by key function is going to apply for an aggregation function over a particular partition. So first the accumulator is going to initialize with the zero value for each and every partition. That's why it is saying that zero value we generally use for the combining purpose for the each key, and it will going to return a different value for that particular key. It is useful when you need to perform both per key aggregation and change the value type during the aggregation process. It takes two functions, sequence operation and combine operation. So as I mentioned that if you want to do, or there is a requirement that the type of input which we are going to use in for the aggregate by key, and do certain kind of aggregation on that input type, and you want to have a different output, then with the help of aggregate by key you can able to achieve it. So whenever we are calling this aggregate by key, we generally pass two argument, and both argument is a function. One is the sequence function and one is the combine function. So sequence function, it will going to do the aggregation on the per partition label, and combine function will going to collect or going to combine all the result of the sequence function which has been applied over a different partition to create a different partition, to create or to do a final result for key and its value, and value is which type of value would be aggregated value, which could be different. The aggregate key operates allow on the aggregate value on the each key, while also maintains the aggregate value type from the different value. So whenever we are doing the aggregate by key, so the aggregation will going to apply on the values of the each key, and the result would be of a different type. So which is one of the main advantage of aggregate by key. Let's understand the aggregate by key with the help of this pictorial representation. So suppose these are the partition which is present in the three different executor. This sequence operation will going to apply in each and every partition, and it will merge the value of the partition. So how it will going to merge it? For the IT, what is the different value? For management, what is the different value? And the format marketing key, what are the different value? So it will going to merge the value and create a partition like this. So if you see the IT, it is the two values are there, and here we are just doing suppose the sum aggregation. So it will not going to do the sum aggregation here. What it will going to do? What is the value? It would be it will be arranged like this only. Here in this partition, sequence operation and merging of the partition will going to happen. So it will create the value like this for each and every key which is present in this partition. Same goes for here. Now the merging. So I am talking about this one, the second function. I was talking about, no, this is the first function, sequence function, and this is the second function, combine function. So here the combining is happening. So how the combining will going to happen? It will, here the shuffling of the data will going to take place, and the data will shuffle from different from this partition to this partition, and it will going to aggregate the value based on the key and arrange the value like this. This IT and all these values are coming from this partition, and this partition. So this partition are the resultant partition which has been generated with the help of this sequence operation and the merging the value of the partition. So we can see for each key the values are organized like this. And after that, if you want to do certain kind of aggregation like sum, mean, max, so that reduce by key will going to apply the aggregation on the top of this value only. Okay, so now let's talk the difference. What is the difference now between reduce by key and aggregate by key? So if you talk about the reduce by key, no, it allows the custom aggregation logic. If you talk about the aggregate by key, no, it allows the custom aggregation logic. So if you want to do any kind of a custom aggregation, so there are two functions, sequence function and the combining function you can, and on top of that, if you want to create a custom logic for aggregation, with the help of aggregate by key, you can able to achieve it. It maintains the aggregated value of the different type. As I mentioned, that input and the output type may be different whenever you are going to use aggregated value. And this is one of the major advantage of using aggregated by key function. If you want the output or the result is of different type, we can use aggregate by key function. It does partial aggregation before shuffling and also reduce the data before the shuffling. So as I told you that here you can see that this sequence operation is doing the partial partial aggregation, means it is doing the aggregation with the help of a sequence and partition here, but this is a partial. So suppose if the data is very huge and the size of this partition is 10 MB, and when this sequence operation takes place in this partition and the data will be present in this format, the size of the data may be reduced to 1 MB. So there is a huge reduction of the data, and when the data will be reduced and when it will going to shuffle the data over the different executor over the network, the shuffling will become very fast because the data is small. Shuffling is happened over the network in the memory, and the data is able to sit well in the memory, and that's why the shuffling become very fast. It provides flexibility in defining the custom aggregation function. As I told you, you can write a logic in the aggregation. So it provides the flexibility that you can define a custom aggregation function, which you can apply with the help of aggregate by key over a RDD, in which the data is stored in key and value pair. It controls the memory and performance with the help of aggregation function. I told you that with the help of aggregation function, first aggregation is applied over the per partition level. The data become very small, and once the data is become very small, it's able to sit in the memory. Less memory will going to consume by the result of the data which is getting. Whatever the resultant function we are going to apply with the help of aggregate by key over a RDD, and hence the shuffling of the data over the network across different executors become very fast. Let's talk about reduce by key. So it's more suitable for cumulative and associative reduction function. So all the reduction function which is applied with the help of a reduce by key, those are cumulative and associative. So this, if you are going to use cumulative and associative reduction operation, then reduce by key will be very performance optimized. It performs logical operation on each partition before shuffling. As I told you, the reduce by key will going to do aggregation or going to apply aggregation function on the each partition label. And once each and every partition gets a result based on the shuffling operation, after that before the shuffling operation, or you can say that suppose we are doing a sum aggregation, so sum aggregation function will going to apply on each and every partition, and then whatever the result it will going to get, it will shuffle, then the data will shuffle to different executor in a different partition. That's why it is saying that the logical operation is performed on each partition before the shuffling. It requires the less memory because the data is going to reduce drastically. If you perform any logical operation on the partition label, the data will reduce, and then with the help of that will going to help to shuffle the data across different partition or over the network very fast. It has a limited flexibility because of the fixed reduction function. So whenever you are going to call this reduce function now for any reduction function, so the reduction function is fixed. This is a very limited flexibility. You can just modify the reduction function, or you can write the custom reduction function. So it provides better it provides better performance due to the logical aggregation. So logical aggregation is happening for every partition. That's why it provides the better performance, because once the aggregation is happen at the local level now for each partition, and after that shuffling of the data will going to happen, the data size will become very less, and over the network those data will be shuffled very fast. So these are the differences between reduce by key and aggregate by key. Thank you. If you like content of my video, then please subscribe my channel, like it, comment on it, and press the bell icon to get notification whenever I add videos.